for a few weeks now. Today we're going to learn about two more characteristics of a quadratic function. That's the focus and the directrix. Touch on some vocabulary here so that you have a visual image of the things we're going to be talking about. All right, we know that when we're dealing with quadratic functions, the shape is a parabola. We also know that the turning point of a parabola is called a vertex. But for the first time today, you're actually going to see the definition of what a parabola is. A parabola is the set of points that are equidistant from a fixed point called the focus and a fixed line called the directrix. So when we've previously graphed quadratic functions, we've never actually plotted these characteristics on the graph, but they exist with every single parabola. There is a focus point inside of your parabola, and then there is an imaginary line on the outside of your parabola called the directrix. Okay, so even though we've never plotted these values before, they exist with every single quadratic function. Now the measurement you need to know for the focus and the directrix is what we call the p-value. All right, p is just the distance between the focus and the vertex, and the same distance from the vertex to the directrix, because every point is an equidistant from the focus and the directrix, and we call that distance p. We know that vertex form is y equals a times x minus h squared plus k. But notice there's no p in this equation. And we know that p is the distance from the focus to the vertex and from the vertex to a directrix. Well, the way that p plays into this is it stems from your a value. You replace the a value with 1 over 4p. So this is what I need you to remember. A equals 1 over 4p. The rest of this equation stays the same as what we've been practicing in the past. Let's take a look at some examples. Here we're given two characteristics about a parabola. We know that the vertex is at -4, 2, and we know that the focus point is at -4, 4. Let's sketch these points on the graph. See, I'm going to use purple. All right, so the vertex is -4, 2. And I'm going to label that with a V for vertex. And the focus point is -4, 4. I'm going to label that with an F. And what we're trying to do is write the equation of this parabola. Well, the equation of a parabola, y equals 1 over 4p, that's just replacing the value of a, times x minus h squared plus k. So starting with what we know, the vertex, this is vertex form after all. My vertex is at -4, 2. And because the focus is always inside, we know that this parabola has to point upward because it needs to wrap around that focus point. So I know that my vertex is at -4, 2. That means my function has shifted to the left 4 and up 2. So I can fill this part in. Left 4 is going to be x plus 4 squared, and up 2 is going to be plus 2. The only thing new I'm going to have to fill in here is I don't have the a value. All I know is how far apart the focus and the vertex are. So looking at my graph, I can see that the focus and the directrix are 2 units apart. Mark this in a different color. Between the focus and the vertex, there are 2 spaces, so p equals 2. I'm just going to plug that into the formula. So it's going to be 1 over 4 times 2. So my final equation is y equals 1 over 8 x plus 4 squared plus 2. And with a vertex at 2, 1, 2, 1, I'm going to label that V for vertex. I also have a directrix at y equals 3. So that's going to cross through the y-axis at 3. Now remember that your parabola always points away from the directrix, so I understand that this parabola points downward. And what I'm trying to do here is write an equation for this particular function. So the formula, 1 over 4p times x minus h squared plus k. Now I can start with the vertex. This is vertex form. My vertex is at 2, 1. The graph has shifted to the right 2 and up 1. So I'm going to have x minus 2 squared plus 1. Now to find the a value, 1 over 4p, I need to look at how far apart the directrix is from the vertex. The directrix and the vertex are 2 units apart, so p equals 2. If I plug in a 2, I would have 1 over 4 times 2. And because this function is pointing down, I need to put a negative in the front. So my final answer would be y equals negative 1 over 8, x minus 2 squared plus 1. Pause the video, and when you're ready to check your answer, press play. All right, to check your answer here, the vertex is at negative 1, 7. And the focus point is at negative 1, 3. Because the focus point is always inside of the parabola, that tells me that our function is pointing downward. Now we have all the information we need to build our formula. So remember, what you want to start with first is the vertex. This function has shifted to the left 1 and up 7, so I'm going to have x plus 1 squared plus 7. To get the a value in the front, we need to calculate p. P is just the distance between the vertex and the focus. Here, the vertex and the focus are 4 units apart, so p equals 4. So out in the front, I would have 1 over 4 times 4. And because this function is pointing downward, I'm also going to put a negative out there. So my final answer is y equals negative 1 over 16 times x plus 1 squared plus 7. Reverse. So we're going to be taking a look at the equation and seeing if we can calculate all of the different characteristics of this function. All right, on this first one, I need to know whether the function points up or down. Well, because I have a positive 1/8, I understand that my function points upward. I can also get my vertex just by looking at the equation. I have x minus 2 squared plus 1. That tells me that the function moves to the right 2 and up 1. Now for some math. The a value on this equation is 1/8. Well, remember the formula, a equals 1 over 4p. We need to solve for p to figure out how far away the focus and the directrix are from the vertex. When you have two fractions that are equal to each other and you want to solve, you just cross multiply. So if I cross multiply here, 1 times 4p is 4p, and 8 times 1 is 8. To get p by itself, I would just divide by 4 on both sides, and I find out that p equals 2. What that tells me is that the focus is 2 units above the vertex. So if I take a look at my graph, I can plot the vertex is 2, 1. I'll label that V for vertex. And the focus point is 2 units above that. So if I go up 2, then my focus point would be at 2, 3. The directrix, I need to go in the opposite direction. If I went up 2 to get the focus, I need to go down 2 places to get the directrix. And that's just going to be a flat line through -1. So we're going through the y-axis at -1, so my directrix is y. We want to start with determining whether our parabola opens up or opens down. Because I have a -2 at the front of my equation, that negative indicates that the graph will be pointing downward. I can also get the vertex by looking at my equation. X plus 4 squared plus 3 shows me that my vertex has shifted to the left 4 and up 3. Now we're going to have to do some calculations to find the value of P. This will allow us to find the focus and the directrix. So remember the formula, A equals 1 over 4P. So to set this up, I have -2 is my A value, equals 1 over 4P. Now when you have a fraction, you can cross multiply. If you have a whole number like -2, we can make it a fraction by putting it over 1. Now we can do the same thing. We're just going to cross multiply. -2 times 4P is -8P. And 1 times 1 is 1. To get P by itself, we're going to divide by -8 on both sides. So my P value, 1 divided by -8, is -0.125. Now remember, the P value just tells you how far away the focus and the directrix are from your vertex. So if I plot my vertex on the graph, -4, 3, this is my vertex, I understand that I'm going to be going down by 0.125 to get the focus point. So the focus point is just going to be slightly lower than the vertex. I need to go down by 0.125. So if I was at -4, 3, and I go down by 0.125, 3 minus 0.125 is 2.875. So the focus point would be at -4, 2.875. The directrix is going to be 0.125, but in the opposite direction. So from the vertex, I would go up by 0.125. So you can see I'm crossing the y-axis slightly above 3. I would be crossing the y-axis at 3.125. To check your answer, press play. All right, which direction does it open? We have a positive value out front. In fact, the value out front would just be a 1. So a positive 1 opens upward. The vertex is at 1, 7 because the graph shifts to the right 1 and up 7. All we really need to do here is calculate the p-value. So we take our A equals 1 over 4p. Remember, if you have two fractions, you can cross multiply. So I'm going to take my whole number 1 and place it over 1. That way I have two fractions and I can cross multiply. 1 times 4p is 4p, and 1 times 1 is 1. To get p by itself, I'm just going to divide by 4 on both sides. And I get p equals 1/4, or 0.25. Remember that the p-value is just the distance between the focus and the vertex, or between the vertex and the directrix. So to find the focus point, I just need to go up by 0.125, and to get the directrix, I need to go down by 0.125. If we look at our graph, my vertex is at 1, 7, So my focus point, I'm going to go up by 0.25. That puts me at 1, 7.25. And for my directrix, I'm going to go down by 0.25. So that puts me at 6.75. Y equals 6.75.